So I want to go over this example of using Chebyshev's theorem because you might run into some, I want to say some assignments, some work, some problems, some challenges in the assignments where you have to use Chebyshev's theorem. So again, here we calculated Chebyshev's theorem in the previous video, and then here's kind of, 2 standard, 3 standard, 4 standard deviations. So here's an example of how you might be asked, in a statistics class like this one, when you're doing your assignments to apply Chebyshev's theorem. And so here's the question. Suppose the midterm test scores of 100 students. And I like to sometimes when I do this stuff, like, just make little notes. And so I'm going to, well, I can't make my notes there, but if I bring this up here, and then I do this here, and then I'm going to do like a little bullet point, and I'm going to make this like, 12, and I'll do n is equal to 100. I'm using a capital in there because it's 100 students. And they had a mean, so a mean is going to be mu. I don't know how to do mu, so I'm just going to do mean, like I don't know how to do it with my keyboard. And so the mean is 70, right? And the standard deviation, and so standard deviation, if we look at that little sheet, which shows us our notation, I've added standard deviation on there. So for a sample, standard deviation is S, variance is S squared, mean is X bar. For a population, capital N, mu, sigma squared, sigma. But here, the standard deviation, so I can't do the symbol for standard. Oh, I can do S. So I'm just going to do S. S is equal to 5. That's my standard deviation. And then we want to know the number of students having test scores between 60 to 80. Well, and I'll do like arrows like this. There we go. And we'll do an arrow here like that. There we go. So what are the number of test scores? What are the number of test scores between 60 to 80? Well, if you look at this data here, right? If our mean is 70, 60, that would be 70 right here. There's our mean, and we want to know how much, how many standard deviations between here and 60, and how many standard deviations between here and 80, and that would be 10, which is 2 standard deviations. So if we have 2 standard deviations on both sides of our mean, 2 standard deviations on both sides of our mean means that at least 75% of the students had a test score between 60 and 80. So down here you see the answer is 75%. Right? So that's how you would apply Chebyshev's theorem in a problem like that. And so here's another one, right? Number of students having test scores between 58 and 82. 58 and 82. So we come back over here and we get this data here, and we'll just do this again because I kind of like this format, and we'll bring it over to this one, and we'll just raise this up, and then we'll bring this down, and we'll paste that in. And then we have between 58, so we'll do 58 here, and we'll have 82 up here. So we added a little bit to it. So the difference between 70 and 58, we divide that by standard deviations, we get 2.4, and we get 2.4 going the other way. So our z-score is 2.4. So if we use the 1 minus 1 over z squared formula for Chebyshev's theorem, we get 1 minus 1 over 2.4 squared, or we get 82.6% of students had test scores between 58 and 82. So that's kind of interesting, right? We're talking about descriptive statistics. We talked about visual representations of data in the module 2, using those as descriptive statistics. In this module 3, we're using numeric representations of data as descriptive statistics. And so here's a numeric representation of data that gives us insight. It describes, it's a descriptive statistic. It gives us insight into our data. And it's Chebyshev's theorem. And when we calculate it, we could see things like, okay, like 82.6% of our students have test scores between 58 and 82. Why is this applicable? Like, you're probably not going to do this as a teacher, but if you are like trying to make money in the stock market, or tracking like futures for oil commodities because you are in the energy business and you need to hedge against drops in prices, and maybe also do some arbitrage. And arbitrage is where you're buying at one price and selling at another price to make money. And maybe you're going to do some arbitrage. Like, statistics becomes not only still might not be interesting, but it's super valuable, and it can make the difference between you dining at great restaurants and taking great vacations and having a great car and a great house and providing really well for your family and doing something else. So, at that point, statistics becomes really relevant. Like, what are the odds, that we're going to make money? Let's calculate those. And then let's place our bets. Like, I kid you not, that's how the world, at higher levels works. All right, so that's more on Chebyshev's theorem applied. That's Chebyshev's theorem applied.